Welcome to The Explainer. Today, we're going to dive into a really elegant algorithm that, believe it or not, quietly powers most of the modern internet. It's an idea so powerful, it actually turned a rejected academic paper into a multi-billion-dollar industry.
So let's start with a question. What's the invisible thread that connects all these services you probably use every single day? They all have to solve the exact same massive problem. How do you grow and shrink on demand without completely breaking everything?
Well, the answer is a revolutionary concept called consistent hashing. It solved a problem that honestly could have crippled the internet's growth. And today, we're going to break down exactly how it works. Okay, so to really get this, we first have to understand the fragile system we used to have. Before 1997, trying to distribute data across a bunch of servers was, well, it was kind of a nightmare. See, back in the early days, systems used a method called simple hashing. You take some data, hash it to get a number, and then use the modulo operator, which is just a fancy way of finding the remainder after division, to assign it to one of your n servers. And this worked just fine, as long as n, the number of servers, never, ever changed. And the difference here is just night and day. With simple hashing, if just one server went down, or heck, even if you added a new one, the n in your formula changed, and that caused a total system-wide meltdown. Nearly every single piece of data had to be moved, triggering this massive data stampede. It was completely unsustainable. All this chaos pushed a team at MIT, including this brilliant student named Danny Lewin, to come up with a beautifully simple and really powerful solution back in 1997. They imagined the entire range of possible hash values not as a straight line, but as a circle, what they called a hash ring. And this simple shift in perspective from a line to a circle is the key to the whole thing. The mechanism is just brilliant in its simplicity. So you use the same function to place both your servers and your data onto this ring. Then, to figure out where a piece of data belongs, you just land on its spot on the ring and take a little walk clockwise until you bump into the first server you see. That's its home. Simple as that. And here is the magic. If a server suddenly disappears, maybe it crashes or needs maintenance, its data doesn't cause a system-wide panic. Nope, it just gracefully shifts over to its immediate neighbor on the ring. The rest of the system? Completely untouched. No massive reshuffle. And this is where the mathematical beauty of it really shines. The amount of disruption is absolutely minimal and perfectly proportional. If you have n servers and you remove one, only about one end of the data needs to move. It is the most efficient way to handle this, period. But okay, there was one more little challenge to solve to make the system perfectly balanced. Because, randomness isn't always fair. What happens if, just by pure chance, your servers all clump together on one side of the ring? You could end up with one server being responsible for this huge arc, while others handle just these tiny little slices. This creates what's called a hotspot, a server that's just getting hammered with way too much work. The solution is another really clever layer on top of this, called virtual nodes. So instead of placing a server on the ring just once, you give it multiple identities, multiple personalities like server 1-A, server 1-B, server 1-C, and you scatter them all around the ring. By doing this, you're basically smoothing out the randomness. Each physical server is now responsible for a whole bunch of small, separate segments of the ring, and that ensures the data load gets spread out much, much more evenly. It's what stops any single server from getting totally overwhelmed. So, how did this cool academic idea become a multi-billion-dollar industry? Well, that brings us to the incredible story of a company called Akamai. This definitely wasn't an overnight success. The whole journey started with Danny Lewin's research at MIT. They turned the idea into a business plan, entered this big MIT competition, and they lost. But they founded a company anyway, called Akamai. And their big break came when a major sports website had a total crisis. You're not going to believe this, but the original research paper was actually rejected from a major computer science conference with this exact feedback. It's one of the great ironies in tech history. A concept that was literally called useless in practice would go on to become the backbone of the modern internet. So a week after their breakthrough with March Madness, they got another huge chance. A bootleg trailer for a new Star Wars movie started circulating, and Akamai distributed it. The traffic was so insane that Apple.com, the official host, crashed almost instantly. But Akamai's network, built on consistent hashing, handled it without even breaking a sweat. A week later, a very impressed Steve Jobs called them, on April Fool's Day, of all days, to try and buy the company. After that, the idea just took off. It became the fundamental scaling solution for the largest companies in the world, which answers our first question. From Amazon's core databases to Discord's chat servers, this ring is absolutely everywhere.
And what's really amazing is that the application of this idea has grown so far beyond just distributing data on servers. It's become this general purpose tool for allocating any kind of resource.
I mean, today, engineers use it for all sorts of clever things. Need to roll out a new feature to exactly 5% of your users? Hash their user IDs onto a ring. Need to make sure a user always hits the same backend server to maintain their shopping cart? Use a hash ring. It's just a fundamental pattern in modern software design. So, the crucial point here, the big takeaway, is that this algorithm gives the internet its elasticity. It's the reason services can add or remove servers on the fly to handle huge, unpredictable spikes in demand without collapsing under the pressure. It's just a powerful reminder that sometimes the most profound solutions are hidden inside the simplest shapes. The next time you stream a movie or load your favorite website, you'll know there's a really good chance this elegant little ring is working hard behind the scenes to make it all just happen. Thanks for tuning in.